Hi, my name is Shabam Shah. I'm the co-founder and CTO of AssetNode. AssetNode automatically maps out your external assets and monitors them for changes in security issues to prevent serious breaches. So the first thing that I want to discuss in this presentation is avoiding the blind spots. And when I talk about that, I really talk about first understanding what the modern attack surface looks like. The modern attack surface is any system, information, resource, or asset that's exposed to attacks from threat actors. Understanding your attack surface and identifying and remediating exposure is absolutely key to securing your assets. That might sound straightforward, but it isn't exactly, because what does a modern attack surface really consist of? Well, with a modern attack surface, you've got to understand that security doesn't exist in a vacuum. At the end of the day, your attack surface is a reflection of your current development practices and technologies. Historically, it's been understood that the attack surface is relatively straightforward, and infrastructure was mostly hosted and managed internally. Software projects were more structured and gated, and change was relatively slow and had heavy governance. However, these days, companies have shifted to a cloud-first architecture, and they have adopted continuous deployment and DevOps practices. The exposed attack surfaces of these organizations have become much more fluid and evolved much more rapidly. One key trend is the use of third-party technologies and products to augment internal processes and support business growth objectives. This has led to new challenges in securing an organization's attack surface. One of the other things to understand is third-party technologies is a common blind spot. Organizations are using more and more third parties day by day, and these technologies are often managed by completely separate companies. They have attack surfaces that may not have been explored yet. There are a number of benefits associated with using third parties, but often the impact of those technologies on the security of your systems is overlooked. Often companies will assume that third-party technology is free from security risk, and this can create a blind spot that can provide a foothold for an attacker within an organization. Ultimately, you can't outsource your security risk, and it's important for organizations to proactively identify and monitor their security exposure if they want to protect their attack surface. So how do we identify security exposure with third-party technologies? The first step is getting asset awareness. The first and perhaps the most important step is to understand what you have. There's a really popular saying that we go by in the attack surface management space, which is you can't protect what you don't know you have. In a modern attack surface, this is often easier said than done. Most organizations struggle with understanding the full scope of their attack surface. And this is especially true when it comes to third-party technologies employed across the attack surface. Often it's overlooked assets that can have the greatest impact. So how do we improve asset awareness? Some strategies to improve asset awareness include automating things. So depending on the organization, without automation, you will often struggle to keep up with the pace of change. A point-in-time list of assets is usually out of date within a week and isn't that useful. And another thing that's important with asset awareness is not relying on being told what you have, but focusing on aggregating asset data from technical sources like Route 53, Cert Transparency, DNS, Active Directory, and so forth. More strategies to improve asset awareness include taking an outside-in approach. It's a really good way that you can start focusing on your external attack surface from the outside-in approach, and you can start working from that point onwards. You'll be surprised at what you have exposed to the internet if you take this approach. Another approach is moving beyond the IP-based thinking, understanding that your application assets are more than just IP addresses, and your attack surface consists of many things, including your third parties. Another strategy is seeking out context. So having a holistic list of your assets is great, but the real value is the context, understanding what technologies you're running, mapping out the interconnectedness of the systems and identifying ephemeral issues, and of course, not forgetting about your third-party attack surface. Your attack surface extends beyond just the assets you own and control. SaaS platforms are a great example of this, and a lot of companies use many SaaS platforms, which they may not consider as a part of their attack surface, but for an attacker, this isn't the case. These are also considered as a part of your attack surface. they need to be mapped out and included as a part of your understanding of your assets. Once you've effectively mapped out your third-party assets and technologies, you should have a system to keep that up to date so you can begin to focus on evaluating the security of these assets. One of the things that you can also do when you're looking at source code and when you're looking at attack surfaces is doing source code analysis. When running third-party software on your infrastructure, it's typically possible to read the source code through reverse engineering. You can decompile the source code, and it opens up a possibility of verifying that certain security flaws do not exist within the product or third party. While this requires some offensive security skills, this can be a really good way to understand the software you're running on your attack surface. You can read through the source code of this third-party software, and you can verify that it's not vulnerable to specific attack vectors. One warning I will say is that reverse engineering source code typically breaks EULAs and SLASAs, so it's something to check before you start reverse engineering source code. Some of the tools that you can use to reverse engineer source code can be found here. For Java, there's a tool called JDGUI or Procyon, which can both be used to decompile Jar files back to the source code. For ASP.NET and C#, there's a tool called ILSpy, which can be found at the GitHub link, which can also be used to reverse DLL files back to C# or ASP.NET code. For scripting languages like PHP, Perl, and Python, you can usually just read the source code directly as it's a scripting language. You simply obtain a copy of the source code from the local disk and start performing source code analysis. Once you've obtained a copy of the source code, first you need to attempt to map out the attack surface of the third-party application. This depends on the language and framework the application is written in. However, typically there is a file that defines the routes, which often leads to the controllers which are processing user input. When you initially start mapping out all the routes, map out all the routes that do not require any authentication, and then trying to discover security flaws in the pre-authentication functionality. Flaws within the pre-authentication functionality are usually the most critical ones because they can expose your organization to external attacks from anyone. Some tools that you can use when you're performing source code analysis include semgrep and Groudit. For Ruby on Rails, there's a tool called Brakeman. For Python, there's a tool called Bandit. And for more comprehensive automated source code analysis, consider using something like CodeQL, especially if you can compile the source code. All of these tools are super helpful when it comes to auditing source code because they can usually find a lot of the low-hanging fruit before you do your own manual source code analysis. One example that I want to point out here is Teradici Pcoip Manager. So this is an example where I found this software running on Facebook. So you can see there's a screenshot here of the subdomain on fb.com, which is owned by Facebook. And you can see that the version string returned says PCOIP Connection Manager. In this, you can also see that I've discovered this same software on AWS Marketplace. So one of the things that you can often do is spin up the software using AWS Marketplace or Azure Marketplace and start taking a look at the source code. In this example, I've identified that Facebook is running PCOIP Connection Manager on their attack surface, and I've been able to get the source code by spinning up a copy on AWS Marketplace. So this is the snippet of code from Teradici Pcoip Manager. One of the vulnerabilities that was identified after auditing this code was that the seed used for random was insecure. And this random function, random.nextBytes, was insecure because the seed could ultimately be cracked. In this case, it would be possible for an attacker to potentially work out what the next sessions are going to be by cracking the seed. By default in Java, depending on which Java function you're using, the random.nextBytes functionality may be insecure by default. So depending on what random functionality it is, if it's secure random, then it's usually okay. But in this case, it wasn't. It was the default Java util random. Another vulnerability that I found in Teradici Pcoip Manager was that it was reading arbitrary XML from a post request, and it was parsing this XML without any protections in place. You can see here that it's reading the XML and it's eventually parsing it, and in the line which says common utils.parse XML input. This input ultimately ended up to this function. So from source to sink, this is where it ended up. And one thing that was really interesting about here was it was using a SAX builder to parse the XML. By default, the SAX builder is vulnerable to a vulnerability called XML entity injection, external XML entity injection, which lets you read local files and also perform arbitrary network requests through the vulnerability. So the final request to this endpoint looks something like this. I was able to send a post request to the specific endpoint that was reading the XML. And I was able to include some XML that would read from an arbitrary URL, a DTD file. In this example, you can see that in this example, ultimately, this led to server-side request forgery and also the ability to read local files. Something that I want to quickly talk about today is also the process of finding vulnerabilities in JAMF. So I was fortunate enough earlier this year to take a look at JAMF source code and look for vulnerabilities in that as well. I found that after reversing the source code from the jar file back to Java source code, the first thing that I analyzed was the routes and the corresponding server-side functionality. For Java applications running on Tomcat, this is often found in the web.xml file. I tested all of the pre-authentication functionality inside JAMF because I was curious about server-side request forgery flaws. So I wasn't able to find any pre-authentication bugs, but what this led to was discovering all the places inside JAMF source code that used HTTP clients to connect to servers via outbound calls. In this example, you can see that I was able to discover a function called getBytes from SSL mutual auth endpoint. This function was responsible for executing a HTTP client request to an arbitrary URL. So as a regular procedure when it comes to source code analysis, you're typically trying to discover from source to sink or sink to source. When I say source, I mean where the user input is happening. And when I say sink, I mean where the user input is being processed. In this scenario, we've discussed sink, where the HTTP request is being made. From the sink, we're going to now discover the source of where it came from. Tracing this function back in the source code, I was able to find a single result that referenced this function specifically. And this was called getImage. In this getImage function, it took a URL in and it ultimately called the endpoint, the function that I just showed in the previous slide. So by looking at this getImage function, we were able to trace it back even further to another function called edu features settings test HTML response.java. You can see that the image is retrieved through this functionality, and the SSL endpoint is being passed to get base64 encoded image without client auth. The SSL endpoint is being read from the HTTP request from this.request.get parameter image URL. So this ultimately means that we may have a potential server-side request forgery vulnerability inside JAMF. There is a HTTP request that we can send, which takes in an image URL, and it ultimately ends up at the HTTP client where it executes the GET request. Luckily, there were clues in the source code for where this functionality was located, because one of the tricky things is understanding where you can actually find this source code within the web application. So within some of the source code, I found this snippet of code, which said essentially edu features settings test.html. By understanding that this was the endpoint, I was able to recreate it in my browser. So it looks something like this. When I went to my JAMF panel and I authenticated as a user, as an admin user, I was able to go to this endpoint, which essentially had a field for test image URL. It was possible to put in an arbitrary URL, and it was possible to click the test button to make this request to the URL using the functionality we just demonstrated in the previous slides. This is what the final HTTP request looked like when we were requesting this endpoint. You can see that we were discussing the image URL earlier. You can see the image URL here in this slide. You can see that we've put in example.com just as a proof of concept. And as a response, what was really amazing is we got the full HTTP response back in a base64 format. So the response contained the whole HTTP response in a base64 format, and this worked for any URL. So essentially, what this vulnerability let you do is use your JAMF instance to request arbitrary URLs on the network and return the full response. This can be problematic specifically in scenarios where your JAMF instance is located on an internal network where requests that are being made are coming from a privileged position. There could be requests that are being made to internal web applications or services or servers, or even in some scenarios, if your JAMF instance is hosted on a cloud environment, requests can be made to the AWS metadata IP to potentially steal secret keys from the AWS metadata API. So one of the things we need to understand from this SSRF is the impact. We found a server-side request forgery flaw, but what does it really mean? Is the functionality reachable by unauthenticated remote users? Well, in this case, for this vulnerability, that's not the case. It's only accessible to authenticated JAMF administrator users. So the impact is considerably lower if it was compared to if it was accessible to all users. And what does the vulnerability allow an attacker to do or gain? What is the severity of the vulnerability? Well, in this case, an attacker would already have to be authenticated to JAMF. But if they were, they would be able to access arbitrary URLs on the internal network through this vulnerability. The severity of this vulnerability really depends on who has access to JAMF in that manner and who can potentially execute these requests. But if someone was able to brute force an instance of JAMF and gain access to an administrator user, they could definitely use a vulnerability like this one to attack and gain further access to the internal network or services running on the internal network. So the criticality and severity is still somewhat high. And another question to ask is, can the attacker leverage this vulnerability to impact other services on the same network? So definitely in this case, they can leverage this vulnerability to impact other services because they can make arbitrary HTTP requests to any service on the internal network. An attacker can potentially also gain confidential documents and affect the availability of other third-party applications through these HTTP requests. So when it comes to mitigating the security risk, it's really important to assess vendors and third-party technologies. When you're looking to utilize third-party technologies in your environment, and in particular for critical systems and processes, it's important to understand how the vendor manages the security of their products. You can't really outsource your risk. Ultimately, this impact is with you. And most product and technology vendors will tell you that they have good security practices, but ultimately, actions speak louder than words. When something is critical to your business, it's worth understanding the potential security risk. Security isn't a binary state. It's constantly evolving, and no software is free from bugs. It's important to understand how vendors manage and react to security vulnerabilities as opposed to the mere presence of vulnerabilities. Some things to look out for include, does the vendor have a vulnerability disclosure process? So in this case with JAMF, they definitely did, and I'll go into a little bit of detail about that process in a little bit. Another thing to look for is, how do they react to reported vulnerabilities? Do they disclose reported vulnerabilities? Do they take reported vulnerabilities seriously and remediate them quickly? Do they have resources and talent dedicated to security? And do they have certifications that encompass broad processes and security practices? For example, SOC 2 certification, in particular Type 2. A good example of reporting a vulnerability was when I reported this vulnerability to JAMF. They have a defined vulnerability disclosure process that we use to submit the vulnerability. They were responsive and gave the vulnerability the due diligence necessary and worked on a fix very quickly. They also enabled and encouraged disclosure, which is a really good sign when working with vendors. This indicated that addressing those security vulnerabilities in their products is a priority and it was taken seriously. JAMF's AWS monitoring tools noticed the anomalous behavior and investigation was started. They recognized it was an SSRF after inspecting it, the IP address doing the behavior was blocked, and the JAMF Pro instance doing the exploit was disabled. The web application firewall rules were put in place to block access to that endpoint for all of JAMF Cloud. And a fix was merged to JAMF Pro RC within 3 days of exploitation. So this is really above and beyond when it comes to most vendors' responses to security vulnerabilities. I was really happy with how seriously JNUC took this server-side request forgery vulnerability after I discovered it and reported it to their program. Another thing with third-party technologies is that applying patches quickly is important in managing your exposure. However, it is reactive. When it comes to third-party technologies specifically, applying an offensive security mindset to find and address issues in these technologies in a proactive way can put you ahead of attackers and can significantly improve your security posture. Doing this on a continuous basis will keep you on top of the changes and evolution of underlying assets. There are three key improvements that organizations can make to achieve this. Improving their asset awareness. This includes not just assets and systems that you develop and deploy yourself, but also vendor products and third-party technologies. Shifting to a continuous assessment, monitoring model, and mindset, which is essentially because modern attack surfaces are constantly evolving, and you need to be looking for security exposures on a continuous basis so that you're not caught off guard. Another idea is focusing on impact and automation, optimizing for assets and technologies that are critical to your business and automating where possible. One final note is that security is hard. In our experience, even large, well-resourced organizations struggle to get it right all of the time. There's a lot of advice out there, and it's focused on sowing fear and shame into organizations, which is not productive. Security is not a destination, it's a journey. Focus on the continuous improvement and adapt your attack surface as it evolves and grows, and you will be a step ahead. Thanks everyone for listening.